Hi everyone, welcome back. My name is Lutza and you're watching my channel, The Space Koala. Today I'm back with another PixInsight video, and this time it's more of a tutorial slash I'll be showing you how I process my Hubble Palette images. So you can see that in reality it only takes a few carefully selected steps to get to a very nice image. So you can get your Hubble Palette images looking from something like this to something more like this. The target that I will be processing today is the Tadpoles or Tadpole or Tadpoles Nebula, depending on who you ask. There is at least one tadpole. It is quite bright, but I did a lot of hours on it. I did this with my Celestron C8 telescope and with my ASI1600MM Pro mono camera. Let's get into it. Let's have a look at all the data that I have on the computer. So as you can see, I took these back last November for the most part, and I just got to processing them finally. Of course, I've already done all the pre-processing, but I'll just show you what I did for WBPP. I've actually already showed some of this when I was doing the tutorial on the group keywords. However, so I'm just going to show you how much data I have here in the post calibration. So disregard the other target. This is the main data that we have. So that is 20 hours of hydrogen, 17 hours of oxygen, and 13 hours of sulfur. So that's about 50 hours. And then I have just 40 minutes of RGB each. I think it was a lot of data, but I wish I would have done more sulfur. In any case, let's get down to processing. I will just be working with the drizzle images. I always drizzle just one time without doing like a 2 times drizzle. And so these are the pictures that I have. First of all, I'm just gonna rename them. So this is the red. Then we have the green. I'm not too worried about what the colors look like. Then this is the blue. And then we get to narrowband. This is sulfur, oxygen, and hydrogen. This is looking nice. Let's have a look. It is quite sharp already. I'm trying to see if we can benefit from any deconvolution. Let's have a look at Blur Exterminator here. I will create a preview here so we can look at the most important parts, because what I really want to make sure is that I don't exaggerate. Like, this is really exaggerated in my opinion, both for the stars and I think also for like the non-stellar features. Actually, it doesn't matter that much what I'm doing on the stars because I will not be using these stars, but anyway. And then if you have a look at the bottom right, especially where you see those like bright edges around the nebula and also here on the other right, if you set it to 100%, they look like super artificially sharpened. So I just want to make sure that they are pleasantly sharp, but they're not over sharpened. So that's like the sweet spot I'm trying to find here, going from 0 to like a healthy spot. I think this is different depending on the scene conditions you had, the optics you have, and then also on the image probably. Since I did the drizzle, I always expect that I'm able to recover some extra detail by using deconvolution. And then I also want to make sure that I'm not like over sharpening in these dark areas. So I will just do a before after, because I mean, blurry is almost better than like artificially over sharpened like this. And then I'm happy with this right now. I will just apply it. And then I only have to spend this few minutes the one time, because then I'm most likely going to apply the same exact settings on the other 2 narrowband images. Like, let's apply it on the oxygen and then on the sulfur. So these are the narrowband images deconvolved, and now I have to look at the broadband images. I will do a preview on the blue image and focus on the cluster where I have most of the brightest stars and see what to do with those halos. And then once you're happy, you can just apply it on the star images. Well, I started on the blue, but I will apply the exact same settings on the red and on the green stars. Okay, now that we have like nice looking stars and sharp everything, it's time to have a look at the data that we have and whether we need any like noise reduction or anything like that. For sure, I will not even be looking at the RGB images, but the narrowband data, absolutely. So here, I know that I have a lot of data, so the only thing that I'm realistically, interested in is like the more darker regions, because that's where I expect to have noise. So I will select some of the darkest regions, like here on the hydrogen. Honestly, I think this looks fine. I would not touch it. And even if I look at some of the other darker regions, they look just fine to me. I mean, this is a healthy amount of noise that you should have. Of course, this is hydrogen. This is where I had the most signal and also the most exposure time. So this is not too surprising. And then oxygen, this is already looking a lot noisier. So I can already see that I need to do something about it. So what I'm going to do, I'm going to duplicate this image to create a mask. I have this script that just applies the histogram auto stretch, on it. So on this duplicate that I have stretched, I will remove the SDF. I will invert it, this inverse image with Command I, and I'm going to touch the curves here on this mask. This will be a mask. And the idea here is I only want to apply noise reduction on the darkest regions. So wherever my picture is light, I want this mask to be black because the black will protect my image from applying too many modifications, if that makes sense. Okay, so I apply this as a mask by dragging it onto my image, and I do a preview of the most important bit, and I open Noise Exterminator. I will do a live preview of that section. And 0.9, the default is a lot, so let's take it down to a more reasonable amount. In my opinion, noise reduction should be undetectable, so I rather leave some noise in than make it look like I blurred the entire thing with the Noise Exterminator. I would just apply it on the whole image now, and I don't need the mask anymore. I can close that. And so I will do exactly the same thing probably on the sulfur, because I probably have, I have very little data there. This is quite noisy. So I immediately duplicate it. I do the same thing, histogram stretch, remove SDF, invert, and then we apply once again a curve stretch. We really want to be protecting the lighter areas, so whatever looks almost black here. Okay, so we have this preview. I think we need a lot more noise reduction than before. Not too much. But now you can see what we need the mask for. Because even if I go like to smudge it out all the way, that part is like not blurred out. Anyway, let's go for a reasonable amount here. Okay, I will apply that. And this is looking a lot better. We don't need a mask anymore. And now these corners are a bit suspicious to me. And normally you would think that it's like a flat issue, but in this case, I'm not at all convinced that's the case, because they seem to be like where the edge of the nebula is. So from this point of view, it's like an unfortunate thing. So what I'm going to do is I will just put the three images together just to verify, because I think that the gradients are easier to spot with an unlinked stretch, because we see the colors. Don't mind the stars, but there's something wrong with them. It seems entirely reasonable to me that this is what the corners look like. And I don't think that this is necessarily an issue, but oh, the stars, look at the stars. These stars, the RGB, are not aligned anymore. Let's open star alignment. I will choose one of my images as a reference, like H. And then I will be using that as a reference. And doing all the other ones. Of course, we need thin plate splines, which is now called this in the new PixInsight. And I will just be deactivating restrict to previews, and I will just be registering all of my images onto the hydrogen. So let's see. Okay, we have the oxygen image, and now let's check if this actually fixed the issue. We can use one of the new functionalities of PixInsight, which is synchronization. So you can drag and drop the label where you press Command, and you see the little dot. That means that they're synchronized. So wherever I navigate on one image, it navigates to the other image on the other view. So then you can actually do blink between the two, and you see that they're ever so slightly shifted, and this is all we needed here to fix the position of the stars. So now we have to do the same exact thing on all the other frames, because now we expect that none of them are necessarily aligned. And we're done. Okay, so now let's put together the RGB image so that we actually have the stars, at least, on those images. I will be opening up channel combination, and I will just put in RG and B, which creates this image. Let's auto stretch, and then let's do a linked stretch to actually see the colors. Well, not too far up, but also not optimal. Okay, so what we have to do is now color calibrate it, right? Of course, we should be using spectrophotometric color calibration. I just set up my filters, which are the ZWO, and then you just drag and drop. And now we find that there's no astrometric solution on the image. And why is that? We know that the original image was solved because in WBPP I had selected image solve. However, when I did the re-register, that didn't automatically transfer the astrometric solution. I think I could have done that actually. I think there's a flag for that, but I didn't do it. So that I could demonstrate to you a few ways of resolving this very quickly. And I think that this is super useful if you're imaging with mono cameras. Okay, so we need to get this image solved. And of course you could solve them one by one, but we have the hydrogen here, and the hydrogen does have the astrometry data. So now we have an easy way with the latest PixInsight to actually transfer that data. If you drag and drop like we did with the synchronize before, but this time you press and hold Control on the Mac, and then I don't know what it's called, it's the Windows key on the Windows, it gets the astrometry data from the image. And now you can just drag and drop, and it was that easy. It is so much quicker than actually having to solve your images again and again or one by one. There are, however, other ways of transferring data which I think are even more convenient if you're imaging with a mono camera. So let me just show you how to do that. You open up the console while you have your image with the valid solution selected, and you type CPAST, that stands for copy astrometry, RGB, which is where you want to copy it, and you hit enter, and then this is literally how long it takes. Obviously, if you just want to do one image, then probably the drag and drop option is quicker. However, you can do much more than just copying a single image with this method. For example, if you have so many images open that you can't even find the view that you want to deal with, it's enough to just go into the process console and you type CPAST, and then you put RGB, and then you put dash dash for, that means a parameter, and then you put source equal H. You can also do copyast, RGB, S, O, R, G, B, and then you put source H. With this, you immediately copy the astrometry to all of those images. This is so much quicker than opening them up one by one, and this is what we needed. And then you can also do copyast star, or like asterisk, and then you put source H, and this does the exact same thing. This will just copy it on every single compatible image that is open here. I'm not going to do that because I have these old images here, and those are not registered, so it would be incorrect to do that. So we're done with the RGB, this is probably fine. And let's get down to the most interesting part, which is the actual SHO image. So to do that, I will just open up color combination again. So in the Hubble palette, I put the S into the red channel, the H into the green channel, and the O into the blue channel. So I will just do that. And we have an image. So, I mean, this is what it looks like at the actual colors, because, I mean, it's all green. I will just name it SHO. I mean, it's not even so extreme, because you can still see some sections that are a bit bluish where you have oxygen, and then the sulfur is literally invisible, so we don't see any red coming through anywhere. The reason that it's all green everywhere, which is probably the correct thing if it was balanced in ratio of the actual signal, is because we have the hydrogen everywhere. However, it looks like a very ugly image to us, because what is pleasing to our eyes is something with a neutral white balance. So actually, that's what the Hubble palette is. The Hubble palette is not quantitatively accurate. It is qualitatively accurate, because you are separating the different gases and you're able to separate them visually. I mean, that's what it's mostly for, that we can separate sulfur and hydrogen, which are both red, and what's more, we shift them down, but we leave them in the same order on the like spectrum of wavelengths. We just shift them down so that our eyes can separate them. So let's just look at the histogram of what this image looks like. So the SHO, and at the top, if we zoom in even more, we can see that we have like a pink peak and a green peak. And the pink peak is just the red and the blue that are perfectly aligned. And then we have the green peak that is so far off to the right, and the right is of course white. So that's why we have this whole green cast on the whole thing. So when we try to do the color calibration, we're going to align these three peaks all with one another. Of course, if we do an unlinked stretch, we can have a look at what it will look like for the most part. So I'm just going to remove these stars because we're not going to be using them. So I know that, I mean, this is already a nice white balance, and I think that many people are happy with this auto balancing of PixInsight, and you can do an unlinked stretch, but let's just save this for later, and we can compare it with it's not my method, but the method that I use, because I think that it is somewhat better. So we're going to do classic color calibration. Classic color calibration is done in two steps. The first one, we need to kind of neutralize the entire image. So for that, we will be opening color calibration background neutralization. And we need to define a background. Now, if you have like a galaxy or a main target in your image, that is very easy, because you just select an area wherever you don't have your main target, and then you don't have any stars, and that would just be your background. Here we don't have any background, so we're just going to have to use the edge as a background, because it's all hydrogen anyway. So that's just going to have to be our neutral-ish background. I will be defining a preview in the corner. I will put the preview into the reference image here. We have these limits here, and we have to have a look at those and have a look at our pixels that are used in the background reference, because it's only going to use the pixels for the creation of the background reference that are within this range. So if we have a look at our values, like 003, 0056 maximum, so we're not going to have an issue, because the range here is from 0 to 01, so we're very far within. It's going to use the entire rectangle, and that is right, that's what we want. So it's all white now, which means it has done some level of like an implicit stretching. I will just re-stretch this, and we can immediately see the effect. Of course, it's all still green, but it's not that obnoxious green anymore. We started seeing many more different tones, and what is our background reference is a much more neutral area right now. So this was the first step. What we're going to have to do now is just ensure that the rest of the image is pleasing to our eyes, meaning the white balance is correct. And that's the second step of the color calibration, where we're going to make the sum of these values white or gray. So we go into color calibration, this time color calibration. This script is the OG color calibration process of PixInsight. So for the reference image, it is correct that I don't put in anything, because then it's automatically going to take my target image. That's what I want. I want my entire image to be balanced to gray or like white. It's just going to take the entirety of the image. And like I said before, it will align those peaks and the histogram on the entire image. And then we have the lower and the higher values here, which is also going to limit which pixels are actually included. But it is set between 0 and almost 100. So that is fine. I turn off structure detection because I'm interested in the entire image and not just like a specific structure in the middle, which would be the case if you had like a galaxy or something that you want to consider. And then we go to the background reference, and here we're going to be using the preview that we've already created, which is the already neutralized background here. And here we have to pay more attention to those numbers, because we see that we did those like implicit stretch, and now we have values of like 0, 1.5, 0.14, 0.16 even. And that is actually not going to enter into that range specified there. So I have to increase that to include all of them, because I want the entire rectangle to be included. So it is, I just set it to 0.2, but I could also just put it up all the way. It would make no difference, because either way the entire rectangle is going to be considered. And then I apply that, and this is already looking good. But if I stretch it with the STF, this is on a different level of white balance. I did nothing to this image. I mean, I didn't do any curves, and we still have all these different tones everywhere, so many different color tones. It is so rich. And then if I compare it to the one that was the auto STF balance, we can kind of blink. I will rename this to STF unlinked. And now I can kind of compare the two, blinking. And it's the level of stretch is just one thing, even though they're both the auto stretch at this point. But if you have a look at the middle, like how much richer the middle areas are, and then if you check the corners, actually the one that we did the proper way is still less green. And if I just sync the two and look at the middle, look how much richer it is. I think that there's like a tendency nowadays that a lot of people tend to remove just like all of the green from all images, including from Hubble Palette images. And so they end up this dual color image where it's just blue and this goldish color, which is beautiful, but it is not the Hubble Palette, because if you look up the actual most famous Hubble images, those are super green. Like there's no reason to artificially remove the green, because that tells you something, and it doesn't just tell you something, it makes the tones richer. It helps you have smoother and more beautiful looking gradients. Anyway, that's my opinion. So I just go for the correct white balance, and if there is not like an obvious green cast on it that is taking away from the picture, I leave it the way it is. So long story short, I'm quite happy with the tones of this image. So I'm just gonna do the auto stretching with a linked stretch with the histogram. And so this is the image. The SHO color calibrated and already stretched. There is very little left to do. I mean, there are these like corners and stuff, and they are looking a bit greenish and dark, but I'm not too worried because I'm most likely gonna crop those anyway. But let's see what they look like at the end. Okay, so what is left to do is essentially just to increase the contrast and perhaps the saturation of the image. So I'm gonna open up Curve Transformation. What we're trying to do here is define an S curve that will maximize the range of tonal variety of the image between the darks and the lights. Ideally, the darkest color should be just above black, and then the lightest color should be just below white to maximize the tonal variety. I really want to focus on the middle part here. So what I'm going to do is I will define like a preview of the part that I'm interested in, just so I can focus on that. I will have that as a separate image, and I will just use this to define the S curve that I will use to increase the contrast. So maybe this is not even the darkest. Yeah, anyway, in the meantime, I'm looking kind of at the curves to see where all the darkest data is sitting. And that's the part I'm gonna like draw down a little bit. Now, this looks maybe a bit exaggerated, but it won't be. Because now that we have this dark image, we can really make these super bright areas pop. And so we're gonna try to increase those. And that is already looking not too bad, except that we clipped a little bit of the black and I want to avoid that. So I have to raise the left side a bit. And if I can look at the previous, like before and after, like that is looking gray compared to what we have. However, I still feel like the black is a bit clipped. And we can make the whole thing a bit lighter, not bad. Let's see if we can increase the saturation. Well, as much as the data allows, like not crazy, but a little bit. Yes. That the before and after is crazy, but the black still looks a bit clipped to me. Let's look at some really dark areas, because here I don't want to be losing any detail. Look, if I really bring this down, then I start losing detail. So I want to have it at like the right spot. And then I have a look at the image again. And at this point, we can also make sure that we're not saturating any of the whites. But this is so far from being plain white that I really don't have to worry about bringing this up more. And that's my image. Of course, these corners are a little clipped, but actually if I look at them, they're not technically clipped. And I'm quite happy with the colors and the range that I got. So all that's left to do now is to add some RGB stars on it. And our RGB image is still in the linear stage, color calibrated, and that was really it. And so now we have to stretch this and put them onto our Hubble Palette image. So I will open GHS. Recently, I've been using GHS a lot. When we have the peak, that is like most of our background, and then we have this right-hand side, which is a bit towards the right, and that's like all the red hydrogen nebula that we have. And then the stars and everything else are just like such a tiny amount of data that they're all over the place here to the right, but we just don't see it. So I will just select like the middle and send it to the symmetry point and start stretching. Of course, I have to turn off the SDF. And so I will gently start to stretch it until I can see all of my stars. And then what I want to do is like have a really flat curve. Let's have a look at this cluster. So I just want to compare that everything that wasn't saturated before is still not saturated. So we don't want to see any pixels where before the value was smaller than 1 and now it became 1, because that means that the stretch has actually saturated and we're clipping data. We want to avoid that. I will still apply a tiny bit of protection on the highlights here. I'm not even sure if it's going to apply to any pixels, but I will apply this stretch now. Remember, we only care about the stars here. Like, I don't care about the nebula. We're only using this picture for the stars. Okay, we'll do a second round on this image. I will focus on this cluster in the middle. I've reset the GHS. And what I want is to bring out these faint stars without like making the bright stars even brighter. Like, let's find a super faint star like here. So what I will do is I will put that value into the symmetry point, and then I move a little bit to the left from that value. That will be my starting point for the stretch. And then we do a gentle stretch to make these brighter. And then for the local intensity, I will be doing the opposite of what I did before, because that doesn't look good. So I will kind of be bringing it to the left. It will be a very gentle stretch, like you can barely see it. But if you compare the faint stars, if I stretch a bit more, quite happy with this stretch. I will be applying it on my image. And so we have stretched the RGB image. Now we have to investigate a little bit the stars. Let's have a look at the colors. I will focus on this star cluster here, and I will do a curves transformation with a preview only, like a crazy value, just so I can see the star colors exaggerated. And I have these magenta stars that are really, really ugly. So we have to fix that. And that is, I'm just gonna do an invert with Command I, and I will do an SCNR on them. I will probably do like a quite aggressive one, like with 0.8. Apply it. That should have removed anything green from the inverted image. That in turn, if I invert it back, that it definitely removed all the magenta from the image. In turn, we lost a lot of color. However, if I see the saturated, exaggerated colors, there is some magenta left, but that amount is okay to me because anyway, it's not going to look like this. So now we have to do our actual saturation of the image, and that will just be still, close this, that will still just be with the curves transformation. And I'm not even going to do a preview on this because I would just do it in so many tiny steps. Like I did the smallest amount of saturation increase, and I will just apply it many times while I monitor the stars. And you can see them slowly come to life, but like the orange ones are already much more saturated than the blue ones, and the orange ones seem to be fainter here as well. So I will be applying a luminance mask. So I extract the luminance and I will apply this as a mask while I apply the further steps. The logic behind this is I want the brighter stars to be also more saturated rather than the very small ones that are only a few pixels, and then it just looks like a hot pixel if I exaggerate. And then we start applying further steps to saturate the stars. Okay, I discard that L mask, and so this is what a picture looks like, and maybe after I've removed the stars I would do something further, I don't know. So I use Star Exterminator. Oh, we have our stars. All that's left to do is put these beautiful stars on this nebula. So I will be using a pixel math expression here. I will be using the combine command, and it takes 3 parameters. The first one being the target, where it's just the active view and the window. The second one being the image that you're combining with, and the third one, the operation. And the operation that I'm using here is screen. So I will just put the second parameter here, which is RGB stars. And then the third is just the operation that we're using, which is screen. And if you open up Star Exterminator, this is the opposite of unscreen, which is something you should select in Star Exterminator if you're going to use the stars again. Because what this does is instead of adding just the pixel values together, it kind of filters it through, if that makes sense. It takes the brightest image and I apply it. And here we have our image with stars. I'm actually going to do one more thing. I'm going to do a tiny bit of morphological transformation because I feel like my stars are a bit too much. Just the tiniest bit. And I'm using erosion or minimum at one of the lowest settings you can do, like it barely changes the image, and then I apply that, and I'm not mad. I really like this image. So this is the image we ended up with. I'm quite happy with the results. I think that I managed to get out all the data that was possible to get out, and I don't think that I've exaggerated with any of the processes. So let me know what you thought, both about the image itself, how it turned out, as well as the process that I used. Do you use the same sort of process, or do you have a different approach? I don't think that there's one right way to do images apart from like the few mandatory steps. It didn't take me too long to process this image because the data was quite good, and at the end of the day, when the telescope is set up correctly and you have enough good quality data, then processing is really a joy and you enjoy the process rather than addressing issues, which is what the reality is. For example, when I have to image from home where it's really light polluted. So in this case, the data was clear, and when you have good quality, clear data, then you really just have to color calibrate and stretch and put some contrast. And then anything else is an extra step, and it depends on the specific image. And this is why I don't really publish like a specific workflow that you should follow end to end for each image, because I think that each image is different. Also, let me know if you would like more of these types of videos, because I'm happy to be making them, because I really enjoy processing images anyway, and that is something that I do anyway. It's just a little extra effort to actually record that. And if people appreciate that, then I will keep doing that. And until next time, I wish you clear skies.